Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you're in the right spot, so go ahead and click the subscribe button. That said, let's get into the current video. I'm going to discuss the integration by parts formula. I will do examples of integration by parts in subsequent videos, and we actually have videos from a long time ago that we posted, but I want to kind of do it in this new format. So go ahead and take a look at those, and then also the upcoming videos as well. But what I want to do in this video is just show you where the integration by parts formula actually comes from. And let me go ahead and start by reminding you of the product rule for derivatives. Okay, so the product rule for derivatives is this differentiation rule that allows me to find the derivative, again, as the name says, of a product of two functions. In other words, if I have a product f times g in order to differentiate this, what I do is I differentiate the first function, so that would be the derivative of f times g of x plus the first factor, which is f of x, times the derivative of the second factor. Okay, so if you are at least halfway through Calc 1, you should be familiar with that formula. And I'm assuming if you're watching this, you're in Calc 2, because if you're interested in integration by parts. Okay, so if I differentiate a product, this is the result. Now, I'm going to clean up the notation a little bit, I'm going to write this in differential form. In other words, dfg, so the derivative of f times g is going to be df times g plus f dg. And in order to just sort of avoid parentheses here, since multiplication is commutative, I'll write this as g df. Okay. Now what I'm going to do is I'm going to take this equation right here and I'm going to rewrite it. I'm going to solve it for, it doesn't really matter which one I pick, let's say I solve it for f dg. So f dg would be equal to dfg minus g df, right? All I did is I subtracted this term to the other side. Now, these are all differentials, and that means we can integrate both sides. So if I integrate this side, integral of f dg would be equal to the integral of dfg minus the integral of g df. And the only thing that I can really do here is the integral of, integral of dx is x, right? So if I take the integral of dfg, that's just going to be fg. That means what I have is the integral of f dg is equal to fg minus the integral of g df. Okay. Now I'm just going to relabel things here and to show you the integration by parts formula that you see in your textbook. I'm going to rewrite the functions f and g as follows. F, I'll say, is the function u, and g is the function v. Then I'm just literally going to replace the letters f and g with u's and v's. I would then have the integral of u dv is equal to uv minus the integral of v du. And this right here is the integration by parts formula that you will see in your calculus textbook. And just one thing I wanted to show you is how this is related to the product rule for derivatives and also what the u and the v are. Really, the u and the v are functions f of x and g of x. In subsequent videos, I will do examples of using integration by parts. This video is simply to show you where the integration by parts formula comes from. Thank you for watching, and please consider subscribing.